record. All right, we're recording. So we're doing Chapter 8, Configuring Distributed File System and Branch Cache. And I'll try to get through this as quickly as possible because I know no matter what we do, it's going to hurt. So an overview of distributed file systems is where we're going to start. So a DFS, or distributed file system, is a role service that enables you to group shares from different servers into a single logical share called a namespace. A namespace server is a Windows server with DFS namespaces role service installed. Namespace root is a folder that's logical starting point for a namespace. A folder can be used to organize the namespace without containing any actual files, or a folder can contain one or more folder targets. A folder target, a UNC path that points to a shared folder hosted on a server. So here's your example. You have your client 1, client 2, DFS server, namespace server. There's your little shares. And then it shows your namespace root. And then you have your example of what your shared folders paths are, target folders, servers. And this just kind of gives you a rundown of what all those are in relation to what was there. Increasing ease of access increases the consequences of file loss. So that's actually something that we've seen a lot in security. Ease of access, ease of use decreases security. So in this case, increasing ease of access increases consequences for file loss. So just remember, a lot of times if you make things easier to access, there's an inverse reaction when it comes to security or file loss or something else. One way to help ensure reliable access to files is to use replication. Replication is the process of creating redundant copies of files on multiple servers. You can replicate the entire DFS namespace. So here's an example, and you can see you have all shares, and then you have, as you can see, they duplicate the DFS replication. You have server 1, server 2, and it's just showing, hey, you can replicate these. Installing and configuring DFS. To use namespaces and replication, you must install DFS namespace role service and DFS replication role service. Use the Add Roles and Features wizard. Oh, hold on one second, guys. I got to pause the recording for 1 second. I have someone that stopped at my door. Hold on. Okay. So use the Add Roles and Features wizard under the File and Storage Services role and the File and ISCSI Services role service to install DFS namespaces and DFS replication using PowerShell. Run the following commandlets. And you can see there, you can install Windows features, and you have the same thing for namespace and replication there as well. Did I see something about cops where? What? Oh, St. Luke's. Well, I hope everyone's okay. Well, hopefully nobody is hurt. Installing and configuring DFS. Continue to manage your namespace and replication using the DFS management console or using PowerShell commandlets. And here's your little DFS management thing that you can chug through from there. Creating a namespace. So there are two types of namespaces: domain-based and standalone. Domain-based enables you to increase its availability by using multiple namespace servers in the same domain. Remember that they have to be in the same domain, and does not include the server name in the namespace. A standalone namespace store information only on the server where it's created and includes the server name in the namespace. Okay, so here's your example. And then, as you can see, this one down here, you have all your different things for shared folder permissions, your local path file, what types of folders are shared, and then what they've got it named as. Standalone namespaces can support up to 50,000 folders and access-based enumeration. Access-based enumeration is a feature of Windows file system that allows users to see only files and folders to which they have been given at least read permission. The maximum numbers of folders and whether access-based enumeration is supported on domain-based namespaces depends on whether you choose Server 2008 mode or 2000 server mode. If you choose 2000 server mode, domain-based namespaces are limited to 5,000 folders and don't support access-based enumeration. After a namespace is created, you add folders to the namespace. And you see here, you have your enable Windows Server 2008 mode, standalone mode, and you see all that stuff there. And then here's an example of a folder, and you see the name of the folder, and then you see what all that stuff is on there. Okay. Configuring referrals and advanced namespace settings. If you want to add fault tolerance and load sharing to a DFS namespace, you need to configure the namespace's properties. Right-click the namespace in DFS management and click Properties. The namespace properties dialog box has 3 tabs: General, Referrals, and Advanced. The General tab supplies information about the namespace, name type, and optional description, and a number of folders in the namespace. The Referrals tab configures how DFS works when there are multiple servers for a namespace root or folder target. When a client attempts to access a namespace root or the underlying folders, it receives a referral. A referral is a list of servers or targets that host the namespace or folder. You can configure the ordering method, which determines the order in which servers are listed in a referral. Lowest cost, random order, and exclude targets outside the client site. Okay, so here's our example. So you see your general, referrals, and advanced tabs, and then you see the ordering method right there. And as you can see, you can also set your cache duration on there. Advanced tab has options for configuring polling and access-based enumeration. In domain-based namespaces, changes are first reported to the server holding the PDC enumerator FSMO role. PDC enumerator then replicates this information to all other domain controllers. Namespace servers poll the PDC enumerator, which might increase the load on the enumerator. Configure polling options on the Advanced tab to reduce the load on the PDC enumerator. And down here you see the Advanced tab. How do you want to optimize it for patrolling? Do you want to do it for consistency or scalability? And then you have enable access-based enumeration for this namespace there on the bottom. Overriding referral order. You might want to override referral settings for a particular folder target. To make changes to specific targets, configure the properties of folder targets. In the DFS management console, click the folder you want to change, right-click the folder target, and click Properties. In the Folders Properties dialog box, click the Advanced tab and select Override Referral Ordering checkbox. And here you go, Advanced, with our checkbox and target priority settings. Creating DFS replication groups. A replication group consists of servers or members that synchronize data in folders so that when a change occurs, all replication group members are updated at once. When creating a replication group, a single file to be replicated must be less than 250 gigabytes. The number of files to be replicated on a volume must be less than 70 million. The total size of all replicated files on a server must be less than 100 terabytes. 2 types of replication groups. Multi-purpose replication group contains 2 or more servers and is used for content sharing and document publication when you want to provide fault tolerance and load balancing for file shares. Replication group for data collection consists of only 2 servers and is used mainly to transfer data from one server to another for backup purposes. Folders specified in replication groups need not be shared folders or part of a DFS namespace. Optimizing DFS replication. Several features can be configured to meet special bandwidth, network configuration, and server load needs. replication topology, replication scheduling, and remote differential compression. Replication topology. This describes the connections used to replicate files between servers. 3 topologies are available for replication groups: hub and spoke. All members of the group synchronize with the hub only. Full mesh, the default topology. Synchronization is bidirectional. All members synchronize with each other, or there's no topology at all, no initial connections, and you have to define them. So here's your topology selection. You can do hub and spoke, which shows you have a nice little diagram there, and then you have full mesh, and then you have the option for no topology. DFS replication scheduling. Scheduling can help manage peak bandwidth needs by forcing replication to occur in off hours. By default, DFS replication tries to use the connection's full bandwidth when replicating files. You can reduce the bandwidth so that replication uses a specified maximum percentage of available bandwidth. Use the DFS management console to configure scheduling. So there you go, you have your edit schedule right there. Remote differential compression, or RDC, is an algorithm used to determine changes that have been made to a file and replicate only those changes. By default, RDC is used during replication. Only pieces of files are transmitted across the network, and this reduces the amount of bandwidth that you use because you don't have the full file transmitting. Use DFS management console to configure RDC. And here's what that looks like. And you have the RDC thing that's highlighted right there. Managing and the staging folder and the conflict and deleted folder. The staging folder is where changed files are cached until they're replicated. By default, each replicated folder contains a hidden staging folder, and then it shows an example there. Default size of the staging folder is 4 gig. When storage reaches 90% of its defined size, the oldest stage files are deleted until it's at 60%. The staging folder should be at least as big as the combined size of the largest 32 files in the replicated folder on primary member. The conflict and delete folder stores files that were deleted and files that have a conflict. Again, the default size is 4 gig. The log of original names of files stored in this folder is written to the conflict deleted manifest XML file in the DFSR private folder. Both the staging folder and the conflict and delete folder can be managed in your DFS management console. So you can see here, you have your path, and then you have your quota, which you can change. And again, path, quota, and it has that there. DFS fault tolerance and load balancing. DFS fault tolerance ensures continuous access to user files. Load balancing is achieved when a user requests a file in a replicated DFS namespace and is directed via referral to one of the DFS servers hosting the namespace. By using DFS namespaces and DFS replication together, you can have both fault tolerance and load balancing on all namespace servers. To configure fault tolerance and load balancing, create identical folders on at least 2 servers and share them, and add the folders to an existing replication group or create a replication group. Using replication diagnosis. DFS includes a useful diagnostic report utility. To use it, right-click the replication group in the left pane of the DFS management console and click Create Diagnostic Report. A wizard guides you through selecting criteria to generate one of 3 types of report: health report, propagation test, and propagation report. And you see right here is your nice little wizard that helps walk you through that. Cat, please don't do that. Those nice little reports there. Cloning and recovering a DFS replication database. Replication setup can be very resource heavy. Much of the work can be eliminated by cloning the DFS replication database. To create a clone, use the export DFSR clone command at PowerShell, and then you have that there. And then you have To import, you have that command there. A DFS replication database could become corrupted. Importing a clone can save more time than allowing the system to do recovery automatically. I don't know if any of you've had to do a full file system recovery, but it takes a very long time. And if you're talking about a server file recovery, it's intense and it takes even longer. So anything you can do to save yourself time, do it. An overview of branch caching. A branch cache is a file sharing technology that allows computers at a branch office to cache files retrieved from a central server across a WAN link. Content information indicates to the client where the file can be retrieved from the branch office. Branch cache supports content stored on Windows Server 2008 R2 and later. Servers running the following protocols. They have to have file server role, web server IIS role, and background intelligent transfer or bits feature. It has two modes of operation: distributed. Cache data is distributed among client computers in the branch office, or hosted. Cache data is stored on one or more file servers in the branch office. Usually when I see this, they do hosted. Unless you have a significantly super small branch office and you have just a tiny amount of people that are going to be there, sometimes you'll see distributed. If you have more than one branch office, you can choose the mode for each office, but only one can be used at each branch office. So here's your example. So on the left, you have your corporate data center, and on the right, you have your host branch cache server and branch office 1. And then on the bottom, you have distributed branch cache server, and then that's for office 2. So those are just an example of how you could possibly do that. Benefits of distributed cache mode. Distributed cache mode is the best solution for small branch offices when having a dedicated server is neither practical or desirable. No extra equipment and no additional resources or personnel for server maintenance are necessary when using branch cache in distributed cache mode. Benefits of hosted cache mode. Hosted cache mode is the best solution for branch offices that already have servers performing other functions. Hosted cache mode offers the following advantage over distributed cache mode: increased availability of cached files and support for multiple subnets. Changes: how branch cache handles changes to cached files. File changes are reflected in the content information clients retrieve from the server hosting the original file. Two versions of content information. There's version 1, which is the original version supported by Windows Server 2008 R2 and later, and Windows 7 and later. Requires client to retrieve the entire file, starting with the part that is changed. Version 2, which is supported by Windows Server 2012 and later, and Windows 8 and later, only the changed part of the file has to be retrieved. With version 1, changes made to the file require the client to retrieve the entire file, starting with the part that's changed, and with version 2, only the changed part of the file must be retrieved. So if you can use version 2 and you want to save bandwidth, obviously use version 2. Installing and configuring branch cache. The procedure to install and configure depends on the type of content you want to cache and whether you're using hosted or distributed caching mode. So here's our nice little table. We have content type installed on content server, or installed on content server, hosted cache, and distributed cache. So we'll start here on the left. File server using the SMMB protocol. Branch cache for network files role service. Branch cache feature on hosting server. Enable branch cache on client. Web server using HTTP or HTTPS. Branch cache feature on hosting server. Enable branch cache on client. Application server using BTS. Branch cache feature on hosting server, and then enable branch cache on client. So this is one that you can keep if you want something to refer back to if you're going to be doing anything with caching. Installing branch cache on a file server. Installing the file server role and the branch cache for network file role service. Configure the hash publication for branch cache group policy. And here's your little file, a wizard thing here. So you have your hash publication enabled, and then you have allow hash publication for shared folders, and then you can go from there. Set the branch cache support tag to on each shared folder that should be cached. Then you see here, allow caching for share, enable branch cache on the file share. Installing branch cache on a web server or an application server. To install branch cache on a web server or application server, install the branch cache feature in add roles and features, or use the PowerShell commandlet install window feature branch cache. Web server role or an application using bits takes advantage of the branch cache service automatically. No additional configuration on the content server is needed. Configuring the server for hosted cache mode. Configuring the server running Windows Server 2008 or later. The process for installed a host cache server. Install the branch cache feature by using add roles and features or PowerShell. Import a cert that's trusted by the branch office client computers. Link the cert to branch cache with the net sh http add SSL cert command. Configure branch cache clients to use branch cache in hosted cache mode. Configuring clients to use branch cache. Branch cache client feature is built into Windows client OSs that support branch cache, so no installation is needed. Enable on client computers with a group policy, and you can see you have your turn on branch cache enabled. Yeah, Gwen had to leave early. She let me know, or they let me know. And then you see here that you have that section there. To configure branch clients to use branch cache in hosted cache mode, open the GPO and navigate to location. Double-click set branch cache hosted cache mode and click enable option button. Type the name of the hosted cache server under options. If using distributed cache mode, enable the set branch cache distributed cache mode policy instead. Okay, you have this one here, set branch cache hosted cache mode, enable, and then you can see how you do the rest there. To configure Windows Firewall on client computers, use a group policy or Windows Firewall with Advanced Security Console to configure inbound rules that allow the following predefined rules. Branch cache content retrieval, HTTP. Branch cache hosted cache server, HTTPS. Branch cache peer discovery, WSD. This rule is required only for distributed cache mode. Troubleshooting branch cache. Okay, some issues to look out for and some of the commands you can use to verify branch cache operation. This is one of those slides that if you're going to be doing troubleshooting, you might want to keep this one. Ensure that group policies are correctly configured and the GPOs are linked to the correct organizational units where the branch cache server and client accounts are. Verify correct cert distribution when using hosted cache mode. Verify the firewall settings. I cannot stress that enough. I don't know how many times I've seen someone go in and change a firewall rule and it has borked like a whole bunch of things, and that's all it is. You need to go change a firewall rule. Verify that all clients are on the same subnet as the branch cache server. Ensure that the peer dist SVC is running on clients and servers when running in distributed caching mode. Use get service peer dist SVC in PowerShell. Make sure all clients are using the same caching mode and that caching is enabled and the caching is not full. That's, you know, when we were talking about the size of the cache. Also remember that there is a default mode, and the more people you have, the larger your default size should be. So check using the netsh branch cache show status all, or PowerShell get BC status and get BC data cache. Be sure to clear application caches such as the web browser cache and the offline file cache on the file server. Okay, this is a configure branch cache with PowerShell cheat sheet section. Speaking of cheat sheets, so you have all your little commandlets, and then you have a description of what they do. These are really nice, especially the clear, disable, enable those if you're going to be doing anything. Usually I find that the reset, release, clear, any sort of thing with commands like that, those are the ones that you end up using the most. So you may just want to go out and save this slide for yourself. All right. See, I told you this one wasn't going to be too bad. Stop share. Okay. So does anyone have any questions for this is our last lecture. Do you just want to go cry in a corner at this point? Okay, so I do have some good news for you guys, and I'm going to leave it recording here for you. The way that when we do the VM hands-on, when they do the clear, there is an easy way to do that, and there's a way that allows you guys to kind of have a little bit of a head start. The only thing that you really have to do in order to clear it is we clear out your VMs that you made. You know how we're setting up the VMs on there. You have to clear those out. However, to give you guys a little bit of a not really a cheat sheet, but it is allowed. If you want to predefine and make all of your NICs before those do not get deleted. So if you want to do those beforehand and walk through those, you can do that and save yourself some time on your hands-on final. So that is something I'm allowed to let you guys do. So keep that in mind. If you want to run through that with me tomorrow, we did that a bit on one of the other classes. So if you want, that was lab 1 that runs through all the network cards. And you can do that and leave those on there, and they do not get erased when you redo the VMs. The only thing that has to be deleted and erased are the VMs that you create on your computers. And then all I have to do is go out and verify that you guys did indeed delete those. And on Monday, and that's all I'm going to do. I won't be like deleting the ISO files or anything like that, but I'll make sure that you guys can that you guys have deleted those, and then I'll go and you guys can go forth from there. So that gives you a little bit of a nice bump and saves you some time. So I was very grateful that Mindy told me that was something that is available that you guys can do before and leave as is. So there you go. There's a nice little time saver for you guys for your hands-on final. And tomorrow I am just going to be going through any questions you guys have on the hands-on final. So I will show you what objectives map to what labs. If you guys want to go through how to do the switches again, then I can go through how to do the switches, and that section's on lab 1. It's all mapped out, but we can do that again. If anyone missed that, we can do that, because that's the one that you can do, and you can leave it there, and that doesn't get erased when we reset the VMs. And then I will walk through anything that you guys have questions on. So, and then I will show you guys and post the guides and walk through those with you. just to make sure that you understand the guides for the hands-on final. So does that sound good? Okay. All right. Are there any questions about, is anyone having problems with Cengage? Please let me know. I've heard it's just being kind of, normal Cengage being slow. But make sure that you, a NIC is a network card. Very funny. So we need to make sure you do all your Cengage stuff, and you need to remember that to do your week 4 test on Monday. Okay, so I'm going to go ahead and stop recording.